let's practice a bit with the number of atoms, which is a basic knowledge of chemistry that is really, really important to have and to be confident. So you may come across different compounds. We could have this. We could have, for example, this. We could have, I don't know why just iron today, but we could have this. We could have another one. Let's go with a more complicated one. Okay. Or you could have also, okay, actually, let's go like this. Let's focus first on the small numbers. So the small number always multiplies whatever they're attached to, as simple as that. So if there is no number, that would mean 1, which means that in this case, we have 1 iron and 1 oxygen.
Which means there's 2.
So it means 2 atoms in total. In fact, let's write down as a little title. So we're working out the number of atoms in compounds. If we have FeF2, what it means is that we still have just 1 ion because it has no number directly attached, but we have 2 fluorines.
Yeah, I understand.
The number is attached next to it. Exactly. Here, the bracket multiplies everything that
so that means O has 2, H has 2, and Fe has 1.
That's it.
So that means it'll be 5 altogether.
Exactly, altogether 5 atoms. And this is a bit more complicated. We have iron, nitrogen, and oxygen. Iron is still 1 because it has no number attached to it. Nitrogen
has 2, and O has 5.
Actually, we times it. That's important.
Oh, 6.
So it would be times by 2. It would be 6. Exactly. So this is what the small number tells us. We need to be really confident to calculate the number of atoms. This is useful because when we balance chemical equations, we come across different numbers, and we would have numbers like this, big in front. For example, let's do 3FeF2, similar to before. Those big numbers, they can only be used to balance equations. And what this means, it tells us that there are 2 molecules of iron oxide present. So the number multiplies everything in front. Okay? So it's important to not get confused of what that means. What this means is that we have 3 molecules of iron fluoride. So we would have iron, we would have 3 of them. And fluorine, it multiplies it, we would have 6. 2 times 3 is equal to 6. Why? Because what this means, remember the big number in front, which we see in balancing equation, it means that there are that many molecules. So in this case, we have 3 of iron fluoride. Not the correct representation, but just to give an idea. Okay, and we use this number to balance equations, which means that the little number can never be changed when we do equations because when we balance them, because it tells us how many atoms are present in the compound, and the compound has a very specific chemical formula. While the big number in front, it's called the stoichiometric coefficient, and this tells us, and this balances out equations. Let's look at a very simple equation that we could balance. Let's say that we have fluorine, lithium plus fluorine to give lithium fluoride. This is the chemical equation. Lithium reacts with fluorine to form lithium fluoride. As we see, we have different numbers on the side. This means that there are 2 fluorine present. Okay, we can actually list them if we want to give it a nice and clear representation. On the left-hand side, we have 1 lithium because it has no numbers, and then 2 fluorine. On the right-hand side, same, 1 and 1. But please notice that it tells it's unbalanced because there are 2 fluorines on the left, and 1 on the right. We cannot ever do this because this changes the identity of the atom. That's not.
So if you times F by 2 on the right side, that means you have to times it on the left side.
It means that you need to time the whole thing. So we would put a big 2 in front, and this would change both of them. Yeah, but then notice, lithium is not balanced, so we need to put a big 2 in front. The key thing, we can only use big numbers. We can never put little numbers next to the elements because this changes the identity of the compounds. That's really important. Okay.
If you did that though,